Okay, so in this section, we're going to go ahead and finish up 12.6, the binomial theorem. Okay, so this is part 2, binomial theorem. Okay, so the binomial theorem uses factorial, so let's begin with an introduction to that. So hopefully you looked on your calculator to see if you have this. Okay, so the notation looks like this, some number, and then an exclamation point. Okay, so what this means is n times the number before it, times the number before that, times the number before that, until you get 3, 2, 1. Okay. And note that we've defined 0 factorial to equal 1. Okay. So for example, suppose we need to find the following without a calculator. So let's start off without a calculator so you understand. Find the following. So suppose that I wanted to find 8 factorial. So that would be 8 times 7 times 6 times 5 times 4, 3, 2, 1. Okay, it's all multiplication. Okay, so you could punch that all into your calculator and you would get 40,320. Okay. So now check with your factorial button and see that you do get that answer. Okay. If you do 3 factorial, this one's an easy one to check. That's just 3 times 2 times 1. So that will be 6. So just check your factorial button. Okay. And if we are doing this, 10 factorial over 7 factorial, this could be done easily by hand. 10 times 9 times 8, 7, 6, 5, 4, 3, 2, and 1. And over here, this is 7, 6, 5, 4, 3, 2, 1. But then all of this cancels out, right? This whole thing right here all cancels out. So we get 720 because 9 times 8, 72 times 10, 720. Okay, so a lot of these division of factorials are not as complicated as they look because you end up canceling a lot of the numbers. Okay, so why don't you try this one, see if you can do all the canceling. 17 factorial over 13 factorial, and then do the simple multiplication at the end. Okay, so go ahead and hit the pause button. Okay, so you should have gotten 57,120. Okay, so that's how factorials work. Let's take a look at the definition of this. Symbol. Definition of, okay, here's the thing. So every single book uses N and R for the formulas that are coming up. And it's very easy to write fast and that R ends up looking like an N. So just be careful when you're taking notes. Okay, so if R and n, okay, are integers with zero less than or equal to r, which is less than or equal to n, then that's an n. This is the r. Okay. So this symbol here, this notation here, okay, is defined to be n factorial over r factorial. So careful, make sure that looks like an r, not an n, times n minus r factorial. Okay. All right. You also have a button. So here you can use the NCR button. So if you have this button on your calculator, you can use this. And I included a video on how to use this if you're using a TI 83 or 84, okay, which is a little more tricky to find this button on the graphing calculator. So if you have a scientific calculator, but I don't think many phone calculators, even if you turn it sideways, will have it. I don't have it. But if you have a regular scientific calculator, not a graphing calculator, it's easy to find this button. It's an actual button. Whereas on the graphing calculator, you have to go into one of the functions, the probability function, to find it. Okay, but they're there. Okay, so like I said, I included a video on how to find this button if you're using a graphing calculator. Okay, if you can't find it, you'll have to Google your type of calculator. Okay. All right, so let's take a look at an example of this. Evaluate. And let's do this one. 7, 5. 7, choose 5. So according to this formula, 7 is n. So I'm going to do 7 factorial here. And then r is 5. So 5 factorial here. And 7 minus 5 factorial. Okay, so we're going to work this out. 7 factorial over 5 factorial, 2 factorial. Okay, so 7 times 6, and then the rest of it will cancel with 5 factorial, right? So all of this here will cancel, and the 2 will cancel, so I end up with 21. Okay, so go ahead and try this one, so that if you don't have a calculator, you can see that it's very easy to compute these here. If you don't even have a factorial button or the NCR button. Okay, so go ahead and give this one a try. Hit the pause button. Okay, so hopefully you got 84. Okay, all right. And check if you do have the NCR button, check that you are using it correctly, and check to see that you are getting 21 and 84 for these two problems. Okay, so let's take a look at the binomial theorem. So I already showed you the Pascal's triangle. So this is just another way to come up with those coefficients that we were getting in Pascal's triangle. This is just, I don't know, maybe a more sophisticated way of doing it. Okay, so if n is a natural number, natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Then x plus y to the nth power is given by the following. So x plus y to the nth will be, so here it's going to be whatever the n is, 0. And whatever that first term is, whether it's x or 2x or 3x, it's that first term to the nth. And choose 1. And this decreases by 1. Okay. And then n choose 2. And this now decreases by 2. And this is 2. And you keep doing this for all of your terms. So you get n choose r, x to the n minus r, y to the r, all the way to the very end till these two numbers finally match up. And you get y to the n. Okay. And this is the same thing as saying the summation, starting from 0 to n, and choose r, x to the n minus r, y to the r. So this might be an easier way of remembering the formula. Okay. You just do one at a time. Plug in 0, get the first term. Plug in 1, get the second term. Plug in 2. Okay. So what this is basically saying is that the coefficient of x to the n minus r, y to the r is n choose r, which is that formula we were just doing. Okay. So that's the coefficient. So that's just another way of finding those numbers that we found using Pascal's triangle, which is great if we have higher powers than 6 or 7, right? Or even 10, because you don't want to be sitting there doing Pascal's triangle if you're doing x plus y to the 24th power, right? Okay. All right, so let's just check to see how this works with something that we're familiar with. So let's do power of 4 since we were able to find that using Pascal's triangle. Okay, but now we'll do it using the binomial theorem. X plus y to the 4th power using binomial theorem. Okay. Okay, so x plus y to the 4th is, we start off with 0, right? X to the 4th, and then 1. That top number is always going to be n, so it's always going to be 4. X cubed y, 4 2. Oops. 4, 3, until you get to 4, 4, okay? Which is right now. Okay, so then we can go ahead and punch that in, and we get 1. And then punching that in, we get 4. Punching that one in, we get 6. And punching that in, we get 4. And punching 4, 4 in, we get 1. Okay, so you get the same answer if you were to use Pascal's triangle. We did 4th power, so this is the row we would want. And we can see those are the coefficients. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Okay, so this is just another way to use to find the coefficients of a binomial expansion. Okay. What is really handy is this next one. Okay, so finding a particular term in a binomial expansion. Okay, so Pascal's triangle, you would have to multiply the entire thing, and not multiply the entire thing, but go through the full pyramid, come up with all the coefficients, and then do all of the multiplications to come up with it. Here, we have this nice little formula so that the term containing the factor, make sure you copy this correctly, x to the r. This is an r, not an n. X to the r in the expansion of x plus y to the, this one is an n. So you're raising this binomial to the nth power, and you're trying to find the term that contains x to the r. Okay, so clearly r is going to be less than n. Okay, and the way you find that term is by using this n. Again, make sure you're writing these clearly so you can tell between the n's and the r's. N, choose n minus r. And then over here, you're going to take whatever your first term is. We're calling it x. It could be 2a, 3a, 5a. Okay, whatever that first term is, we'll just call it x. To the r, y. Again, y just represents that second term. That second term could be 3b. Okay, we would have to plug in 3b there for that y. To the n minus r. Okay, so again, make sure your n's and your r's are clear. Okay, so let's take a look at an example of this. Find the term containing x to the 10th. So that's the r. The smaller one is the r in the expansion of x plus 2a to the 15th. So that's the n. The larger exponent is the n. Okay. All right, so we're going to use this formula right over here. Okay. So we're going to use n, so that's 15, and then n minus r. Okay. And then again, here, this represents the first term, whatever the first term is. In this case, it happens to be x as well. Okay. Raised to the r. R is the smaller one. Okay. And then y, again, y represents the second term. So in this case, it's 2a. Okay. So it's 2a. And then it's going to be n minus r, the larger exponent minus the smaller one. Okay. And then we go ahead and we work this out. 15, 5, x to the 10th. And then this here is 2a to the 5th. Okay. Again, if you don't have that n choose r button, then let's just do this by hand. Okay, I don't have the n choose r button. So let's just go ahead and do this. 15 factorial, 5 factorial, and then the difference. 15 minus 5 factorial. X to the 10th. 2a to the 5th. That's going to be 32. A to the 5th. Okay. And let's go ahead and work this out. This is going to be 10 factorial. Okay, so 15, 14, 13, 12, 11, and then 10 all the way to 1 will cancel out with 10 all the way to 1 over here. 5, 4, 3, 2, 1. Okay, so these guys will cancel out. And let's see if we can cancel anything else out. 3 times 5 is 15, cancels with 15. 4 and 12 will cancel. That's 2. So 2 and 14 will cancel. Okay. And so when I work all of this out, here, hold on. Let's get that. Okay. So I multiply all of the numbers out, including this 32. So it's 7 times 13 times 3 times 11 times 32. And you should end up getting this. Okay. So again, if you don't have this button, no, not a big deal. Just do it by hand the way I just did it. A lot of things end up canceling anyway. Okay. So the term, so again, this problem is asking you to find the term, right? Because when you multiply this out, you raise this to the 15th power. You got a ton of terms there. Okay, so you got a bunch of terms there, and we want to know what is the term that contains x to the 10th? That would be this one. This is the term that contains it. Okay, all right. Okay, so that is it for binomial theorem. If you have any questions, make sure you message me.